All right, guys, welcome back to the channel. Today, got a great video for you. 6.1, you should have grabbed your Unit 6 packet off of the front table. It has a tan cover this year. And yeah, let's get into it by opening up to the first page here. Our whole unit here is about inverse functions. So in 6.1, we're just going to talk about functions, function notation, and function composition or composite functions. So let's get into it. We normally write functions with this type of notation where a function is f of x, is how we say that, equals the equation, or g of x equals an equation. And the next one we usually use is h of x, and then you'd have an equation. Okay, so let's perform an operation. If we see something like this, f plus g of x, what interpreted that means the f of x function being added to the g of x function. So what we'll do is something like this: 3x, that's the f of x function, and we're going to add it to the g of x function. Now, if you remember back in Unit 1, if we're adding, we can just drop the parentheses and combine like terms. And that would be your answer. Okay, subtraction. What if we wanted to take the f of x function and subtract it to the g of x function? Now, if you remember, in subtraction, we want to distribute the negative. It's going to make this negative and that positive. And when we combine our like terms, we will get x plus 4. Whole new equation. Okay, let's multiply 3x multiplied by the g of x function. And this is just multiplication. We'll distribute the 3x and we'll get 6x squared minus 12x. And lastly, we'll divide. We'll put our 3x, our f of x function, over the g of x, like this. 2x minus 4. And then to simplify these division problems, we factor. So on the bottom, I'll GCF. And then I look and see, can either of my GCFs cancel anything out front? Well, in this case, they can't. So that would be my answer. 3x over 2, x minus 2. Okay. Let's practice a couple more of these. Maybe we'll just do one. Let's do this x squared one over here. Okay, first I'm going to do the f plus g of x. We have our x squared plus 1 being added to our g of x function, x minus 2. When we're adding, we can drop the parentheses and combine like terms. These are like terms there. Okay, notice I wrote this in the normal form we've seen all year with the largest exponent first, the next exponent second, and then our constant, just a regular term, out back. Now, this looks like a Bing problem, but we're not going to Bing it. This will just be our final answer. Okay, let's subtract them. We'll distribute this negative. It'll make it negative and positive. And when we combine like terms, we'll get x squared minus x this time. And then we have 1 plus 2 is our 3. Those are these two like terms. Okay, we'll multiply now. Okay, now in this one up here, all we had to do was distribute a single term in. This one is 2 term by 2 term. A binomial times a binomial is what we call this. And to solve it, we FOIL. X squared times x is x to the third. X squared times 2 is negative 2x squared. 1 times x is x. and 1 times negative 2 is negative 2. Okay, did we get all that right? I'm just checking my work. Okay, and we don't have any like terms to combine, and they're in an order, so that would be our answer. And lastly, we will divide these two. F of x on top, g of x on bottom. Notice how in all these other ones I put them in parentheses. With the division, we don't necessarily need to. And can I factor either? Well, this one kind of looks like a difference of squares, but because that's not a negative, it cannot factor. The bottom can't factor, so this would be the answer for the division one. Okay, so those are our basic operations for functions and a little bit of function notation, f of x and g of x, and then we'll get into some h of x in a minute. We can use whatever letter. Those are just usually the three that we use. Okay. Evaluating for a function. So if I gave you this function, and then I ask you f of smiley face, what this means is if there whatever number or thing is in there, we replace it in parentheses for x. So it gets written right here and right there for x. Okay, so if we wanted to do this with the heart, we would have 2 parenthesis the heart squared plus the heart minus 1. Okay, now some practical use. Not sure why those are even in there in the first place. We'll take a 3. This 3 needs to be plugged in right there and right there. 2 times 3 squared plus the 3 minus a 1. Now we need to actually evaluate it. Okay, we're actually evaluating these numbers. In this situation right there, the question is always, do I multiply the 2 and the 3 first, or do I square the 3 first? Well, order of operations tells us exponents come before multiplication. So this is going to be 9. We square it first. 2 times 9 is 18, plus 3 minus 1. 18 plus 3 is 21, minus 1. And our answer is 20. So another way we can write this is f of 3, with this function being f of x, equals 20. When we plug in 3 for those x's, we get out a number 20. Evaluating. Okay. Let's bring 2 equations into this. Flip the page. Flip the page. I'll give you a second by inserting a picture or a sticker. I miss you guys. Here we go. Given that this is f of x and this is g of x, what if we wanted f plus g of 2? Of 2. Okay? We're going to take the 3x and we're going to plug in the 2. We're going to take the g of x and we're going to plug in the 2. Six. 2 minus 5 is negative 3. So what I'm doing is I'm taking this number and I'm plugging it into both f of x and g of x. For f of x, I got a 6. For g of x, I got a negative 3. Now this sign tells us how to finish it off. Add. 6 plus negative 3 is 3. And that's our answer. Okay, what if we wanted to subtract them with a negative 1 being plugged in? Okay, g of x comes first. Notice that? They switched it on us. G of x comes first. That will change things. Negative 1 minus 5. I'm taking this negative 1, putting it into g of x. We get out a negative 6. F is just 3x, so 3 times negative 1 is that negative 3. And our sign is a negative. Negative 6 minus negative 3 is negative 3. Add those. Okay. All right, now we're gonna do what's called composition. Composition. Let's see, where should we start here? I guess this is a good way to say it. What if we wanted to plug, instead of a number, but an entire equation in for g of x? What if we wanted to take the whole f of x equation and plug it in for g of x? This is how I've always seen it written. I guess we can write it like this too, where we're plugging in this into this. We're plugging in f into g. Let me show you how this works. Okay, so look. In this case right here, we have our equations. We have 3 of them this time. F of x, g of x, and h of x. First, this is telling us f of g of x. So we want the f function of the g of x. Putting g into f. So we're taking g and putting it into f. Here's f. There's the x for f. We're putting g into f. See that? This is the g of x function. This is the f of x function. Putting g into f, and now we solve. Distribute. That's the answer. Okay, what if we wanted to flip it around? What if we wanted to put f into g? F into g. Okay, well, f is 3x, g is this. So if we wanted to do that, it would look like this. Taking wherever that x is and putting in our f of x function into g. Now there's no like terms there, so this would just be the answer. Okay, what if we wanted to put h into f? So we start with f, the 3, and there's the x. We're putting in h. Distribute. Okay. What if I wanted to put the answer of f of 3 into g? Well, first I need to figure out what is f of 3. So if I have the f of x function, I need to plug in a 3. So f of 3 is 9. Now we take that 9 and we plug it into g. Okay, see how I did that? I took a 3. Watch my arrows. Took a 3. Plugged it into f. Got 9. Took that 9. Plugged it into g. And 9 plus 4 is 13. Okay, backwards. What if I wanted to take, well, I guess not backwards, the last one, but a new one. I want to take f of 2. So first I need to find f of 2. If f of x is 3x, I'm doing 3 times 2, 6. Now we take that 6, and where are we going to plug it in? Into h. $35. Okay, one more. H of negative 2, this is a different notation, but it's the same. We just go from the inside out. H of negative 2, plug that into g. Take whatever that is, plug it into f. So h of negative 2. This is the h function with a negative 2 plugged in for x. Negative 2 squared is 4 minus 1 is 3. So h of negative 2 is 3. Now we plug that into g. 3 plus 4. Now we take that and we plug it into f. And we get, of course, done new one. We're getting there. Promise. Okay. If this is our function f of x, and we want to know f of 3, we just plug in a 3 for all x's. We did this last unit. We just didn't use this notation. We did this when using test points. 3 plus 2 is 5. 3 minus 4 is negative 1. 3 minus 2 is 1. 3 minus 4 is negative 1. Negative 5 over negative 1 is positive 5. So I know that f of 3 is positive 5. Okay, we could do that same thing with 2. I'm going to skip it. If we did the same thing with n, we're going to have something that looks like this, right? With the n in place of the x. Okay, but what about taking f of 3 and plugging it in to f again? Well, we already found f of 3. f of 3 equals 5. So now I'm just finding f of 5. Plugging it in for x. Okay, and then you would solve and get a number. Okay, we do the same thing right there. Now what about graphs? Okay. If I have f of 0, and if this is the function, this is f of x, it's just in graph form. Don't let it scare you, this is super easy. If I'm plugging in a 0 for f, into f of x, sorry, I'm putting that 0 in for what letter? X. So what we want to do is find where is 0 on the graph for x. Right there. That's 0. And then where is the actual function? If this red line is the function, it's right there at 3. Okay, when f is 2, that's right here. This is 2. Where's the function? Negative 1. Where is our function at positive 4? Right there. Positive 4, where? At f of negative 2. Okay. Super close here. If this is f of x, and this is g of x, where is g of 5? And then we'll plug it into f of x. So g of 5, okay, x. When x is 5 on g of x, where's the graph? It's at 3. So g of 5 is 3. So now we take that 3 and we plug it into f. Here's 3. Where's f? 3. Okay, g of 2, so I'll erase some of this. G of 2, here, g is at 2. Where's the graph? It's at 5. So now we take the 5, and then we plug it again back into g. This is how you plug in. We find the 5, and then where were we? We were at 3. I guess these both equal 3. So g of 2 is 3. And then I guess to write the other one, f of g of 5 is also 3. Okay, that's the video. If you've made it this far, drop a comment below. Like this video. Don't forget to subscribe. We got more coming at you later this year. And I hope for you that lunch is ready. Enjoy, do your homework,